All right, 6th grade. I need everyone to make sure that your name is on both packets. So make sure your name's on the front of both packets. If you finished your Chapter 9 test on Friday, they have been in the grade book. I think I put them in. It was Saturday morning that I entered all of them in. There were a lot of over 100%. There were a lot of 100%. You guys did a great job. As of now, with the ones from Friday, the average was a 92%. So once I pass those back, as well as your quizzes, either tomorrow or Wednesday, I'll tell you the new updated average. And remember, I never passed back the 9-1 to 9-4 quiz, 9-1 to 9-3 quiz, just because we had a lot of people out that day. I still have them. They were in progress book, so hopefully you saw what you got on that. I will pass them both back at the same time so we can go over them. You're going to have one more test or quiz. I need to see how Chapter 10 goes. So it will be either a Chapter 10 quiz or test, depending on how far we get. So I will let you know, because I'd like to spend a week and a half on this chapter. If we don't get it all done, that's okay, because I need to leave time to review for your final, which is your last cumulative exam. So we're almost done. Chapter 10 is all about triangles, polygons, and quadrilaterals. The title of it is Measurement, Area, and Volume. This is a really good chapter to help you prepare for geometry. There's everything that we learn in this chapter you'll see again in 2 years. So I wish we had a lot of time to spend on it, but we don't, but that's okay. Very, very interesting chapter. The first part of it should be somewhat of a review. You should remember a lot of that. So I will probably go a little bit faster through the first 3 or 4 sections. Then we'll spend a lot of time on the back half of it, okay, with the time that we have left. So I had you guys do a warm-up on Friday and then finish it today if you needed to while people were finishing the test. So we're going to go through that together in a second. Before we do, there's a warm-up that we're going to do together, which is number 1. It says find the sum of the interior angles for each of the given polygons. So I know you know how many degrees are in a triangle. Does anyone know the formula that we use to find how many degrees there are on the inside angles of a polygon? Ben? No, that doesn't, no. No. Gia? Okay. What did you get for that? Okay, that's not right. Kevin? Nope. Okay, I want you guys to write this next to where it says warm up. N minus 2 times 180 degrees. Okay, good. So we know a triangle has 180 degrees. Marion? Yeah, just put it on my desk. The formula that you will learn again in geometry that works for every single polygon is the number of sides minus 2 times 180 degrees is how many, the sum of interior angles of any polygon. So n minus 2 times 180 is something that I want you to remember. Okay? You're going to need that for this whole chapter. So a pentagon, Gio, you said has how many sides? Good. So if a pentagon has 5 sides, to find the sum of interior angles, all you do is take 5 minus 2 times 180 degrees. So someone tell us what's 3 times 180? Joseph? Say that again. You said 540, right? Good. So 540 degrees is the sum of interior angles of a pentagon. So that's for a pentagon. Shane, how many sides does a nonagon have? Good. A nonagon has 9 sides. So if a nonagon has 9 sides, we take n minus 2 times 180 degrees. So 9 minus 2, so we have 7 times 180. What is the sum of interior angles, Jackie? Good, 1,260 degrees. The sum of interior angles of any polygon is n minus 2 times 180. Make sure you circle or put a star by that formula. I want you to make sure you remember that. Does anyone know, you might not know this, so I'm going to ask anyways, the sum of exterior angles of a polygon? Do you know how many degrees or what the formula is to find the sum of exterior angles? That's for interior. Neil? Nope. I want you to write down underneath or above that sum of exterior angles. And I want you to put 360 degrees next to it. There are always a total of 360 degrees for exterior angles. That's for any polygon. You'll see that in Chapter 8 of Geometry. So I'll say that again. The sum of exterior angles of any polygon is 360 degrees. So there's not really a formula. You just need to remember this is the total amount. Okay? That's it. This is for interior. This is for exterior. Okay, and we're going to do more of that tomorrow. I just wanted to bring them up today. Gio? Exterior, Gio. This is for exterior. Always. I'll show you tomorrow. Promise. Okay, number 2 on the warm-up, I had you guys do on your own. So let's run through these. For 2A, what is the best description or word that says what that triangle is? David? Good. The first one is isosceles. Letter B, Jordan? Good. Scalene. Camille, letter C? Good. Right triangle. Letter D, Alexis? Good. Equilateral. Letter E, Mike? Good. Acute. Letter F, Evan? Good job. Obtuse. This is a review, which is why it's an introduction to the chapter. You should have already had those done, but are there any questions? Okay, example 1, A, B, and C. I also wanted you guys to try those on your own when you were finished with your test, so let's go over those. Drew, did you get to 1A? Okay, Josh, 1A. Good. What was X? Okay, X is 8, but not acute. Oh, wait. Sorry, it says classified by angles. You're good. My fault, Josh. So, letter A, as long as you did that after your test, you should have gotten that X is 8. By the angles, it's acute. Joseph, letter B? Which one, letter B? Letter A? Okay. Josh, can you explain what you did for letter A to get 8? Okay, but tell me how would you do that? Put your hand down, I can't hear you. You plugged in numbers. Okay, that's not how you do it. Camille. Good job. So we did this in chapter 9. All you guys are doing is taking the interior angles, you're adding them up, setting it equal to 180. You know there's 180 degrees in a triangle. And then after you combine like terms, hold on one second, Jordan. We get 15x plus 60 equals 180. From there, subtract 60 on both sides. Divide by 15. We get x is 8. Joseph, does that make sense? Okay, Jordan? Say that again. Oh, yes. But we don't need to on these ones. But yes, if you had to, we would plug 8 in. Yep. And let me actually ask you guys that. If we did, Jordan asked to find the angle measures, would we just plug 8 in? Yes. What would we get for this angle and what would we get for this angle if we actually had to find the measurement? Kevin? Good. Good job. So the top one is 36 degrees, and then the bottom one, both base angles would be 72. So yes, to determine what kind of triangle that is by the angles, plug it back in. We know they're all less than 90, so it's acute. Okay, Skylar, letter B, what did you get for x? Good. For letter B, x was 23. And Skylar, what kind of triangle was that? Good. X is 23. It is an obtuse triangle. If you plugged it back in, this angle is 115 degrees. And this one, I believe, is 53 degrees. And this one they already gave us, which was 12 degrees. If you have one angle over 90 degrees, it's going to be obtuse. Any questions on B? And again, we did these in 9, so it was kind of like a review. Okay, anyone want to tell us what they got for X for letter C? Jackie, what'd you get? Good, X equals 15. Jackie, based on the angles, what kind of triangle is that? Good. So this was 53 degrees, this was 60, and it is an acute triangle. Okay, so again, review, but are there any questions on B or C? Okay, flip over. That was the end of the things you guys had to do on your own. This is new, but it's not that bad. So letter D says the ratio of the angle measures of a triangle is 1 to 3 to 5. So they're giving us a ratio of angles. You will also do this in geometry in 2 years. That's why I like this chapter. If you're given the ratio of angles, all you do is put an X next to them and set it equal to the total amount of interior angles in that figure. So I'll say that again. They give you a ratio of the angles. Basically, they're giving us a hint as to what each angle measurement is equal to. So you're putting an X next to them, setting it equal to the total amount of degrees in that figure. David, did you have your hand up? Oh, I thought that was a hand. Okay, so all we're doing here is combining like terms, solving for X. So 1X plus 3X plus 5X is what? Girls, make sure you're trying to whisper. Good. So we have 9X equals 180. So after we combine like terms, set it equal to, keep it equal to 180. Shane, what's X? Good. X is 20. So that's only the first part of the problem. We need to find the measurement of each angle. So all we have right now is what X is. I am going to write the extended ratios on the side of the smartboard here right now. If we know what X is, we need to find the measurement of each one. So 1X, 1 times 20 is 20 degrees. 3 times 20 is 60 degrees. And 5 times 20 is 100 degrees. So once you find what X is, the important thing is plug that back into the extended ratios. If we add all of those up, do they add up to 180? Yes. Joseph, you had your hand up. Yeah. You okay? Okay. Any questions on letter D? Okay, letter E, I want you guys to try on your own. Same exact setup. So try letter E. It's an extended ratio problem. Girls, get some done. And don't forget about 9th period today. Bye, girls. But you can still come in and work on your own and then work again together. When you're done with letter E, just put your pencil down. Make sure you're following with me, okay? Okay, you need to find each of the angle measurements. Look how we did letter D. That's what you should have written down here, Drew. Okay, most of you guys are done. On E, since you have the extended ratios, we are taking 3x plus 5x, plus 12x, which is equal to 180. After we combine like terms, we get 20x equals 180. Mike, what did you get for x? Good. X is 9, which is correct. Once you find what x is, you need to plug that back into the extended ratios. I keep reading the x on the 12. So what are the 3 angle measurements that we know now for this triangle? Amberly? Yep. Good job. So really, this is the answer that they are looking for. What are the extended ratios? What is each angle measure for the interior angles of this figure? And of course, they're triangles. You'll see that in geometry. Pretty easy, right? Okay, let's go to part 2, and then I want to start part of the next section. Okay, so part 2 says, find the unknown side length of the triangle with the given perimeter, then classify it by its side lengths. Okay, Very similar to part 1 on the first page of the notes. We are given perimeter. We need to find x. How would we set this up? What do you guys think the first step would be? And you should also know how to do this. Neil? Good job. So perimeter is equal to all the sides, and we need to add them up. You guys know to find perimeter, you're just adding up all the sides of a figure. So again, this is not new. This first lesson is pretty much a review. After we combine like terms, what does the second step look like? Kevin? What's x plus x? Nope, careful. X times x is x squared. But what's x plus x? So ready, Kevin? What's 1x plus 1x? There you go. So plus 2x. And that's something that I know gets confusing. Remember, when you're adding, do not add exponents. Just add the coefficients. When you're multiplying, same base, add exponents. At this point, subtract 25 from both sides. So we have 68 equals 2x. Nathan M., what's x? $68 divided by 2. Good. So x is 34 centimeters. What is the measurement of each side length, Gio? So now what are all the sides going to be?
31 centimeters.
Yep.
34 centimeters.
Good. Good job. Based on this triangle, we need to classify by sides. What kind of triangle is that? Again, this is also from 9. Alexis? Good. All the sides are different, so it is a scalene triangle. All the sides are different, so scalene triangle. Give me a head nod. Is this pretty easy so far? It's fun. Good. I like to hear that on a Monday morning. All right, letter B. I just want to do letter B, then we're going to flip to the next page. This one's kind of different because they don't really give you all the sides, and there's not even something on every side. How would you set that up if I wasn't helping you? Jordan? Good. Put an X or whatever letter you like on each side. How do we know to put the same letter on those sides, Ray? Yeah, they have the little tick marks, which means those sides are equal. They are congruent. Okay? What kind of triangle do you think it is before we even solve? Greta? Good. Isosceles. So obviously, whatever we get for x, it's going to be the same for both sides. Let's do it anyways. We know the perimeter here is 64. So we have 64 equals x plus 26. So we're adding up all the sides. Remember, perimeter is distance around. Combine like terms. Kevin, what's x plus x?
2x.
Good job. 2x plus 26. After we solve for x here, we need to subtract 26 from both sides. We get 38 equals 2x. So Ben, what's x? Good. 19 yards. So bless you. We're going to plug 19 in for both x's. So we know the sides of this triangle are 19, 19, and 26. How could we check to make sure that that's correct? Mike, how could we check? Good. And what should it equal, Mike? Good job. Perimeter. Adding up all the sides, make sure you always get what that perimeter is. Camille. Nope, we're going to do it right now. You want to tell us? Good. It is an isosceles triangle because two of the sides are the same. If we had to find angles or knew anything about the angles, those base angles would be exactly the same. Okay. Questions? Okay, I want you to flip over to 10-2 because this is somewhat of a review as well. Yeah, so I want to start 10-2. So here's what this is about. This is also an introduction to polygons and quadrilaterals. The first lesson was an intro to triangles, but we spent so much time, and I added a lot of material to your book for the triangle chapter we just finished. That's why I didn't want to spend too much time on that. So up here are just examples of what a polygon is and what it's not. And we're going to talk a lot about that today and tomorrow. That's why I have a picture of a stop sign and a keyhole on there. We are also going to classify polygons and quadrilaterals. So let me start with giving you guys a definition of a polygon. So right underneath the warm-up, well, not even underneath the warm-up, right where it says define, the word polygon is there. Just make sure that you're writing somewhat small. So you might remember this from last year or from 2 years ago, but a polygon is a closed plane figure whose sides are segments that intersect only at the endpoints. So it has to be a closed plane figure. They only intersect at their endpoints, and everything needs to be a segment. So some kind of curved shape figure is not a polygon. Anything that has an opening that's not closed is not a polygon. Anything that crosses over or overlaps is not a polygon. So I put some pictures up here for us. These 3 pictures right here are not polygons because this one's not closed. This one has a curved side, and this one crosses over in the middle, so it's like overlapping. Does anyone want to take a guess? Why do you think these are regular polygons, but these are just polygons? Jordan? Good job. A regular polygon, it has congruent sides and congruent angles. That's also a big part of geometry. Anytime you hear the word regular, that means the sides and angles are always congruent. If it just says polygon, that means that it fits that definition. It's a closed plane figure. All the sides are segments, and they do not overlap or intersect at all. Camille? It is a polygon. So I can't hear you. What? Well, it could be. They don't always draw these to scale, Camille. So who knows? This could be a little bit longer, but it just might look like it's the same length. But you're exactly right. This could be a regular polygon. We just don't have, this is from your book. We don't have enough information here to prove them, to say, yes, you drew this, so it's regular. I agree with you. The way it's drawn, it looks like it. Yeah. Thank you for bringing that up. But if you do have a regular polygon, I want you to keep in mind all the sides, all the angles are the same. Going back to the first thing we talked about today, do you guys remember what the formula is to find the sum of interior angles of a polygon? What's that formula? The first thing we talked about, Greta. Times. Good job. And I want everyone to try to put that in your brain so you remember that. The sum of interior angles of any polygon is n minus 2 times 180. What is the sum of all exterior angles of a polygon? Amberly. Awesome. It's only 360 degrees. That's every single polygon. That fits this definition. 360 degrees is the sum of exterior angles. Interior is n minus 2 times 180. Keep that in mind. Neil. Because it crosses. Remember, it cannot intersect. The only place that it can intersect is at the endpoints. Not in the middle, not on the side. It's not a polygon. Not a polygon. By definition, not a polygon. Okay? All right, so here's what I want you guys to do. There's a table below. I had mine really, really small. I decided to blow them up. I made them bigger. So the first thing is, we're going to write down everything we know about a quadrilateral. So we know a quadrilateral is a polygon with 4 sides, and we know all quadrilaterals have 360 degrees in them. There's 4 sides. That also fits the formula n minus 2 times 180, because a quadrilateral has 4 sides. 4 minus 2 is 2. 2 times 180 is 360. So quadrilateral, a polygon with 4 sides, there's 360 degrees. Neil? You don't need to draw anything for that one, because any figure with 4 sides can be classified as a quadrilateral. So you don't need to put anything there. I am going to give you guys a flow chart, hopefully tomorrow, maybe Wednesday, that you'll see pictures of all these on, so you don't need to worry about that. Thank you for asking, though, Neil. Okay, a parallelogram. So here's getting more specific. This is a type of a quadrilateral because it has 4 sides. For parallelograms, the reason it's called a parallelogram is both pairs of opposite sides are parallel. So it's a parallelogram because both pairs of parallel sides are parallel. So it has 4 sides, so it's a quadrilateral. It has 2 sets of parallel sides. Remember those little like arrow things I have drawn? That means parallel. Okay, what do we know about a rectangle before I flip the slide? Ray, what do we know about a rectangle? Yes, you can say that. Good. 4 sides, opposite sides are parallel. Good. What else do we know about a rectangle, Neil? Good. All the angles are 90 degrees. What else, Camille? Good. It's a quadrilateral. Abigail? Not all of them on a rectangle. You're thinking of square. Do you want to change that? Good job. 2 opposite sides on a rectangle are congruent. Greta? Good. It's a type of parallelogram, which you could also say it's a quadrilateral. Okay, so that's everything we know about a rectangle. A square, very similar, but on a square we know all the sides are the same. So the only thing that I wrote down here for rectangle is it's a parallelogram. It has 4 right angles. And I want you to add in on your drawing that opposite sides are congruent and opposite sides are parallel. So I'm going to add that into the drawing. So I want you guys to add in, bless you, opposite sides are congruent and opposite sides are parallel. Did you guys learn this? Did they learn this year in your 6th grade math classes? Did they do a chapter like this? Okay. I know they jump around a little bit. This chapter also has surface area and volume in it. I don't know if...
Like adding and subtracting negative numbers.
Oh. Okay. 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 We did that. Yeah. Joseph? Say that again, Joseph. Isn't a square technically a what? Yes, but a rhombus does not always have all right angles. Is that what you're asking? Yeah. Okay, so a square, parallelogram, you can classify it as a parallelogram. You could also say it's a quadrilateral. I just didn't put that on there. There's 4 right angles and 4 congruent sides. Remember, the symbol for congruent is an equal sign with a squiggly line above it. Drew? No, that's what Joseph just said. A rhombus does not always have 4 right angles. A rhombus always has 4 congruent sides, but the angles don't always have to be right angles. Because a rhombus could look like this. I mean, this is obviously not drawn to scale, but it could look something like that where maybe the angles are more or less. They don't always have to be the same, but the sides all have to be the same. Okay. You guys are going to get into a lot more details about that when you take geometry. You'll learn a lot more about each of these polygons. More interesting, but we need to learn the basics first before you get there. Jordan? What do you think? Yeah, it is. A square is always a rectangle, but is a rectangle always a square? No. No. The flow chart that I show you tomorrow will really, really show you guys that. Why is a square always a rectangle? Anything else? Yep. It fits every single classification of a rectangle. A rectangle cannot always be a square because a rectangle is going to have 2 sides congruent that are across from each other and the other 2 that are across from each other congruent. That can't be true for a square. A square has to have every single side congruent. Steve? I don't know. It's from when I took copies of it this morning. I took pictures of this so I could make it bigger. Who knows? There was just a random E there. Neil? only if a rectangle has all congruent sides, which is really then a square. That's the only time that could happen. Yep. Yes, it could be. Yes. Yep. Okay, so since we've talked about a rhombus a lot, a rhombus is a type of quadrilateral. It's a parallelogram because opposite sides are parallel, and it has 4 congruent sides. So I'm going to mark here about the parallel sides. Would you say, Mike? Yeah, but I tried to give you guys some pictures too. That way, you could just draw pictures if you want. So it's a quadrilateral, which can also be classified as a parallelogram. There are 4 congruent sides on a rhombus. These ones, yes, but everything, no. A trapezoid is not. Camille? Opposite sides are parallel. Yep, that's why a rhombus can also be classified as a parallelogram, because opposite sides are parallel and all sides are congruent. But however, we cannot always say and assume that all the angles are right angles. That's not true. Steve? They're arrows indicating parallel. Okay, a trapezoid is not a parallelogram. It is, you can say it's a quadrilateral, and a trapezoid has exactly 1 pair of parallel sides. So here and here. There is something called an isosceles trapezoid, which I'll explain a little bit now. That's not in your book, it's in the geometry book. But if you have something called an isosceles trapezoid, the sides of it they call legs. The legs will always be congruent, and the base angles will always be congruent. That's something, if you guys have Mr. Warnock in 2 years, he'll go into a lot of detail about an isosceles trapezoid compared to a regular one. That is the biggest difference. Do you guys remember how to find the area of a trapezoid? It's kind of a weird formula. Joseph? Nope, that's a parallelogram, but that's okay. Neil? You're close. You're close, but no. You're close. Gio? Nope. Nope. Nathan? You could do that, but there's an easier way. Camille? Divided by 2. So all you do, and we'll get to this later in this chapter, if you wanted to find the area of this, I figured we haven't talked about this one this year, you add the bases, multiply by the height, and then divide by 2. So it's similar to a triangle, but I think it's easier. Whoops, this should be base 2. It's, oh yeah, you guys, a lot of you guys were close. Neil? Yeah, they do it in different orders sometimes. I'll tell you, don't worry about it now. I'll tell you about it, we'll do it in 2 lessons. I think it's in 2 lessons. Okay, 2 more, and then I need to give you guys your homework. So convex, last 2, and then we'll spend more time on this tomorrow. Convex says, and this is from your book, if a segment joining any 2 interior points lies completely within the polygon. I think of convex as pointing outward. Things are pointing outward. Again, from your book, they'd like to say if a segment joining any 2 of the inside points in a polygon lies completely within the polygon, then it's convex. I also like to think of it as the shape is like pointing outward. It's convex. You'll like this one. The definition from your book for concave is not convex. That is from your book. Isn't that required a lot of thinking to come up with, right? But it doesn't bother me, which is why I didn't change it, because all I want you to remember is if a figure is concave, it caves inward. So it caves in, it sinks in, just like this. The book says if you take 2 of the interior points in the figure and draw a segment connecting them, if the segment falls outside the figure, then it's concave. If the segment stays inside it, it's convex. But I think it's easier to say if the shape is all pointing outwards, it's convex. If it's caving inward, some way, some form, it's concave. I think it's easier to explain it like that, which is why I did not change the book's definition. Pretty stupid, I think. Drew? Yeah, but you need to check all the interior points. So I just try to use my common sense and find two that I think might either fall inside or outside. I mean, on this one, there's nothing you could do to get them so the two interior points, and you'd have that segment fall outside. There's nothing. But yes, you're correct. You could pick one here, but check all of them. Okay, who can tell us in your own words, what is the definition of a polygon? Give me those three important things of the polygon. Ray, what's one of them? Good. They only intersect at the endpoints. What else, Abigail? Good. It has to be a closed figure and, Neil? Good. Awesome. They're segments. They cannot be curved. Convex and concave, I want you to remember convex points outward, concave goes inward. Okay. If you have your book, I want you to open it up. If you don't have your book, just stay there and write this down. Sit down. If you have your book, your homework is page 513, and I'll tell you why it's in the book and not in your packet. Numbers 1 through 20. Okay, so in your book, it's really pages 513 and 514, numbers 1 through 20. Okay, if you need to get your book, go ahead. This is just on 10-1, so this should not take you very long because really chapter 9 was all about triangles. Before you guys get packed up, make sure you write down 513. Hold on, Neil. Numbers 1 through 20. I don't have any more, Neil. Yeah, it's on the corner of my desk. Neil, just get one at school.